Sometimes it can get pretty wordy, right? If A is less than B, prove that the average of the squares is greater than the squares of the average. So again, like kind of wordy, but just sort of kind of interpret what's going on here. The average of the squares. So what are the squares? Well, I'm looking at A and B, right? So A squared and B squared. What would the average of that be? So how do you find averages? Like,
You add them up together.
yeah, I don't divide by 2. It wasn't a trick question. Right? You add them together, you divide by 2, that's the average. What's the squares of the average? Well, same idea, right? The average of A and B would be this. And what's the square of that? It's all squared, right? Okay. So prove that the average of the squares, so this one here, is bigger than this, right? So you see what I mean by like, how would I just know that this is bigger than this? Like it's not something that's immediately obvious, right? Would you agree? Or is it?
And it makes sense.
Okay, like if you think about it, it probably makes sense. But like it's not as conclusive as, oh yeah, so therefore they are bigger, right? So cool. So yeah, so what do we have to do? We have to employ our strategies, right? What strategies do we have?
We have lots of strategies.
We do. What's the first one?
Just put everything on one side. And squares can't be liquid.
Yes. Okay. So I think you mean put everything to one side, right?
Yeah.
Yeah. Okay. So with the goal of if you take LHS minus RHS, I'm trying to show that this is bigger than 0. Okay. So like a lot of the times when you start these questions, you just have no idea if it's going to work out or not. Like you know that it's meant to, but you're not exactly sure where you're heading. I think that's just going to come with practice, and like the more questions you see, you'll know exactly which strategy you need to use, right? So let's do LHS minus RHS and see where we end up. Let's go down the rabbit hole. Okay, so what can we do with this? Give me some suggestions.
I mean, expand.
Sure, let's try it. See what happens. A squared plus B squared. We'll sit there for a second. I missed the 4 when I did this one, so just don't make algebraic mistakes. The whole topic is algebraic inequality, so algebraic mistakes are really going to stuff you up if you do that, right? This one, yeah, we can expand it out, okay? A squared plus B squared on 2 minus, what have we got going on here? Minus A squared plus 2AB plus B squared on 4. All right, cool. We're still kind of like, what's going on here, right? Think back to number 2 now. Angus, what was number 2 that we want to do? Okay, so somehow incorporate what we did over here. Like somehow incorporate a square or something. Right now I don't have that, okay? So just want to start like putting stuff together. Like let's put them under a common fraction, right? So let's say that this is 2A squared plus B squared, all on 4. Are we happy with that? Now I'm actually going to draw brackets here because what I want to do is I want to put these under a common denominator. But something that students often forget is that this is a negative and applies to the whole thing, right? So this is actually going to be 2A squared plus 2B squared, and then we're taking away all of these. So I just made the mistake again. So I did the brackets. All on 4. Okay. So far, so good. Again, like I'm not exactly sure where this is heading, but I'm trying to sort of create the situation. And like I said, what's a great way of getting these squares? Well, if you can find a perfect square somewhere in your expression, then that's like a good strategy to try and look for, right? Can we get that? Yeah, well, if you simplify it out, so you end up with A squared, and then this will end up with minus 2AB plus B squared, all on 4, and that's equal to our perfect square again, which is always greater than or equal to 0, right? Sorry? Oh, A less than B, sorry, you're right, yeah. Because they tell us A less than B, so just greater than 0, you're right, yeah. Because A can't be equal to B in this case. Cool. And, I mean, I don't know how much of a concluding statement we need, but I guess if I was in the exam, I'd probably write this statement out again, but therefore this is true. Is what I'm going to write.